So when you saw this problem, a couple things probably happened. The first thing is you probably started seeing the pattern, and you're like, oh, I just need to start factoring. But that's not really what the question asked. The question asked, what is the best, fastest way to determine if it is indeed factorable? Because if you look at the factors of 5, yeah, those are good, but like, think about what you have to multiply those first two things to get that, and eventually get the 60, right? Because, I don't know, let's try something. Let's say this is negative 1, 2, 8, 5, 2x, and this is just x. And then this is, I don't know, negative 5 and 1. You multiply that out, I'm pretty sure you don't get 60 for the middle term. And finding all the factors of 12,852 seems like a mucky mess. But think about this from the sense of a quadratic, from a quadratic formula problem. This would be minus b plus and minus the square root of b squared minus 4 times a times c all over 2a. Now, when we factor things, what kind of answers do we get? Hopefully you're saying, integers, whole numbers. We're not getting fractions, we're not getting decimals, we're not getting anything like that. And so what we need to think about is, well, under what scenario would we get something like that? And in fact, we can get fractions, but what we don't get, turns out, is square roots. Right? We don't get things that don't have perfect squares in the determinant in this b squared minus 4ac. So what we're trying to figure out really is b squared minus 4ac a perfect square? So let's come up with an example like that. And we really haven't gotten deeply into these kinds of factoring problems yet, but let's take an example of one that is, just so you can see what this would look like if it worked. So suppose I had minus 60 plus and minus the square root of, I guess, 60 squared minus 4 times a, and suppose c was 0, all over 2 times a. Okay, so I'm making a 1, c 0, and b this negative 60. Right? So I've made up a new problem, just to show you what it would look like when we know something's factorable. So suppose this is true. So now we get negative 60 plus and minus the square root of 60 squared is just 60 all over 2. And this turns out to be 0 or negative 60, right? Which we could have come up with in a factoring problem, right? If you want to know the equivalent problem, this is x squared minus 60x plus 0 equals 0. And you could have solved that by factoring it out in x and using zero product property. You get this, right? So these are factorable problems. So what we need to determine is b squared minus 4ac a perfect square? If it is, then we're in good shape, and if it is not, then we're not. So this is going to take some computation. So let's look at our discriminant. 3600 is 60 squared minus 4 times a times c. We need a calculator for that. So 4 times 12,852 negative times negative 5. Now how do I decide if this number? So I get 257040. So I'm going to subtract that from 3600 and decide, is that a perfect square? Well, first of all, I get a negative number, so I know that's not a perfect square. But let's pretend like it's not negative. To find out if it's a perfect square, you take the square root of it, and I get 503.43. The second I say point, the second I say decimal, I know it's not a perfect square. So, no, this is not factorable because b squared minus 4ac is not a perfect square. Now you might want to go back and look at a prior problem just to prove to yourself that, wait, this is factorable because the discriminant is a perfect square. Remember, you can only use it on x squared terms, but you could go back quite a ways and look at all these solved problems we have and find that in fact it is a perfect square. Okay, so in this case it is not.